So we keep solving 92. So basically, you have a flat coil rotating at frequency 10 Hz, and the magnetic field produced by 3 pairs of magnets. The axis of rotation coil lies in the plane of coil and is perpendicular to the field. What is the frequency of alternating voltage in a coil? So basically, you have a frequency 10, but you see, so there are 3 events, and when you rotate the 1/3 cycles, then the frequency of the voltage will be the direction of the voltage will be changed. So the frequency is 3 times original 10 is 330 Hertz. So the answer is D. Basically, once you understand this question properly, then you can easily get the answer. Okay, so 93. You have initial potential and ask about what is the total accelerations. So I come up with the first way to solve it is very stupid. The first way to solve it is we know that S theta equals 0. All we have is the gravitational, so the total should be G. S theta equals 0. So A 0, B is 2G, C is 0, D is 2G, E is G. So the answer is E. Okay, so done. We get the answer. Because we know that S theta equals 0, the total acceleration to be 0. It's 0. Okay, so this is the answer. Okay, but I know that you guys will not satisfy this answer. But as I said, in a test, you should use this way to get the answer. Okay, so let me to directly solve it, in general theta you will have G, right? So you have one acceleration, which is the standard tangential acceleration, which is G sine theta. And you also have a normal acceleration, which is v squared over L. And the v squared can be computed by the energy conservation. So v squared is basically 2gl times cosine. The reason is that the change of the gravitational potential become mv squared, and there is a 2. So basically, this is 2g cosine, and you can compute the square them. So you have sine square plus 4 times cosine square, which is 1 minus sine square. Oh, sorry. Sorry. So this is L sine theta. And your AT should be G. What I'm writing about. So theta is here. So you have G cosine. Yeah, so this is G cosine. So all you have is G times cosine square plus 4 sine square. So this can be written as 1 minus sine square. So you have G times 3 sine square plus 1. So this is the answer. So I apologize for my not good writing. Basically, the G cosine is the tangential, and the 2G sine theta is the normal term. Okay, so 94 asks about which one is a Lorentz transformation. A is definitely not correct. B is not correct. Okay, so let me write the Lorentz transformation. So I tell you that this transformation you must remember. By the way, I'm memorizing it. So for C equals to 1, you have So these two are the same, and the rest is this. So basically, you see these two basically are the same if you flip x and t. So this is the key point. When you flip x and t, then these two should be the same. So which one? Which one? Which one? The remaining is what? If you change x and t, then it should flip. It should flip. So which one is correct? So the A is not correct. B is definitely not correct. So C, when we change x and t, then become the same. So the answer is C. The answer is C. Okay, so 25. Okay, you can read the question by yourself. And what you want? What is you want? You want what? You want the unit. You want the cross section. So cross section is the square centimeter. So all we need to is a unit analysis. We want to combine the object which contains the unit. So basically, we have 10 to the 12 protons seconds, and to 10 to the 20 nuclei cm square, and then we have 10 to the 2 proton second, and then we have 10 to the minus 4 called the STR radians. Okay, so the only way to get the cm squared basically is we just use 10 to the 4 2 proton second divided by 10 to the 20 nuclei cm squared, 10 to the 12 proton second, 10 to the 4 stereo, because this has no what we need to is cm squared divided by stereo. So this is the cross section, right? You see the answer is the square centimeter per steradian. So this is the only way to get your cm squared. So compute it, you get the 10 to the negative 26 cm squared steradian. So the answer is C. Answer is C. Okay, so come out with 696. Make us a Morty, a similar one. So basically the maximum Morty, the important thing is the difference of the light path. Okay, so the straight one and the vertical one, horizontal one, the difference is in the some object in the vacuum bound. And he said that the interference has elusive by light wavelengths. So you know that the wavelength is 500 nanometers, and there is a gas in it. So there will be some reflecting index in it. So basically, the light will travel longer, and the light travel longer will give the different light paths of the horizontal and the vertical one. So here comes the key points that your basically your index n minus 1 times the length. Length is the bump times 2. Why is 2? Because 2 comes from, because there are when you in and out, so there's 2. So this is the light path. So the difference of light path should be something called something times lambda, and now we have 40 because it said there are 40 fridges. Okay, so this is the formula what we have. Okay, so basically the change of light path will give the pattern. Basically, this is similar as the optics, like the diffraction or something, refraction or something. So you have n equals to 1 plus m lambda divided by 2l. Okay, so 1 plus 40 fridges, 500 nanometers, 2 times 1 centimeters. So we have n equals to 1 plus 0.0002, which is 1.0002. Okay, so the answer is Which one? The answer is C. The answer is C. Okay, that's it.